the quest for sustainable energy inventors and thinkers for decades. Among these intriguing pursuits is the concept of a self-running generator, a device capable of generating free energy by exploiting high-voltage pulses and cold electricity to charge its battery. This article explores the mechanics of such a generator, its theoretical basis rooted in the Aether field, and its practical design. Energy from the Aether field, theoretical foundations. Energy, as viewed through the lens of the Aether field, is not an absolute entity but a latent possibility waiting to be manifested. This principle aligns with classical mechanics, where potential energy converts to kinetic energy under specific conditions. The Aether field, postulated as an all-pervasive medium, holds the capacity to manifest energy as inertia changes. For example, when a car brakes abruptly, its kinetic energy dissipates as heat and mechanical wear. Similarly, in electronic circuits, the sudden cessation of current flow akin to braking can release significant energy. This phenomenon taps into the Aether field's latent potential, manifesting as high-voltage pulses and cold electricity, a concept extensively analyzed by Charles Proteus Steinmetz in pre-1930s electrical physics. However, after the 1930s, mainstream electrical science took a turn, suppressing revolutionary ideas like those of Steinmetz and Nikola Tesla. This suppression limited technological progress to conventional pathways, sidelining radical innovations such as the self-running generator. How the self-running generator works. The self-running generator operates on principles of magnetic flux changes, pulse generation, and energy recovery. It utilizes a rotor, a wooden or plastic disc, embedded with magnets, paired with coils wound on an iron core. This design leverages the interplay between magnetic and electric fields to generate high-efficiency pulses. Here's a detailed breakdown of its operation. 1. Magnetic flux and induction. When a magnet approaches the iron core of the coil, it induces a magnetic field. This field generates a current in the trigger coil, TC, which activates the transistor. At this stage, the rotor's momentum is converted into electromagnetic energy stored in the system. 2. Sudden current interruption. As the magnet moves past the coil, the magnetic flux collapses, inducing a reverse electromagnetic force, EMF, in the main coil, MC. This reverse EMF generates a high-voltage pulse, sufficient to recharge the system's battery while accelerating the rotor. 3. Energy recycling. The high-voltage pulse, although brief, lasting microseconds, is remarkably effective in replenishing the system's energy. This energy recycling is supplemented by an auxiliary coil, PC, and a small magnet, which compensate for any energy losses and ensure consistent battery charging. Cold electricity and battery charging. A key feature of this generator is the production of cold electricity, a form of energy distinct from conventional electrical current. Cold electricity is characterized by its low temperature and high voltage, making it highly efficient for charging batteries. This unique energy form ensures minimal heat loss, allowing the generator to operate continuously with minimal maintenance. Design and components. The construction of a self-running generator requires precision and careful selection of components. Below is an outline of the essential materials. Rotor and magnets. A circular wooden or plastic disc with embedded neodymium magnets. Coils and iron core. Trigger coil, TC, and main coil, MC, wound together on a soft iron core, ensuring optimal magnetic flux. Transistor and circuitry. A high-voltage NPN transistor, E.G. D13009, for rapid switching. Adjustable resistors and diodes for circuit stabilization. Battery and inverter. A lead-acid battery for energy storage. An inverter to convert DC pulses to usable AC power. Auxiliary magnet and coil, PC. A small magnet and additional coil to enhance energy recovery and ensure consistent operation. Challenges and innovations. While the self-running generator is theoretically sound, practical implementation poses challenges. Energy losses due to resistance, mechanical wear, and material limitations can hinder efficiency. Innovations like improved coil winding techniques, advanced transistors, and optimized magnetic alignment are critical for overcoming these obstacles. Furthermore, precise assembly is essential. Knowledge of geometry, coil impedance, and magnetic field dynamics is necessary to achieve a functional system. Detailed diagrams and instructional resources, like those available on the Overunity Generator blog, can guide enthusiasts in constructing and troubleshooting the device.